In this lesson, we'll explore Hydra, a powerful rendering architecture within OpenUSD. Understanding Hydra enables efficient and flexible rendering of complex 3D scenes. Hydra is a rendering architecture within OpenUSD that provides a high-performance, scalable, and extensible solution for rendering large 3D scenes. It serves as a bridge between the scene description data, such as USD, and the rendering backend. The open and extensible nature of OpenUSD means it supports many different renderers, like Arnold and RenderMan, and OpenUSD's included Hydra Storm renderer offers a simple way for developers to visualize data out of the box. It has three main parts: a scene delegate, which provides the scene information, the render index, which keeps track of changes and manages the scene, and the render delegate, which uses both the render index and the scene delegate to visualize scene information to create the final image. Hydra operates on one or more scene delegates, which is a hierarchical representation of the scene data. It processes the scene delegates into an abstract renderable scene, which the render delegates can use to generate rendering instructions tailored for the specific rendering backend. This approach decouples the scene data from the rendering backend, allowing for flexibility and extensibility. Hydra supports various render delegate plugins, enabling developers to create custom rendering backends or extend existing ones. OpenUSD ships with HD Storm, a real-time rasterizer render delegate with OpenGL, Metal, and Vulkan implementations. HD Storm is leveraged by USD View and many other tools. Hydra also ships with HD Tiny and HD Embry, which can be used as examples of how to implement render delegates. Understanding Hydra enables efficient and flexible rendering of complex 3D scenes. In this lesson, we learned Hydra is a rendering architecture within OpenUSD that bridges scene data and rendering backends. It operates on a scene delegate and enables render delegate plugins to generate rendering instructions for specific backends. Hydra supports various rendering backends and techniques, including rasterization and ray tracing. It provides extensibility through plugins and custom rendering backends. And developers can interact with Hydra using Python bindings. With its support for various rendering techniques, extensibility, and decoupling of scene data from rendering backends, Hydra empowers users to create work in large scenes. We encourage you to explore Hydra further and leverage its capabilities in your OpenUSD projects. Thanks for watching. Check out the following resources, and we'll see you in the next lesson.